This chapter is on gravitational field. This is a summary of the things you must know when you study this chapter. A. Gravitational field. Understand that gravitational field is an example of a force field. Number 2. Know that the gravitational field can be expressed by drawing field lines. Number 3. Explain how the field lines is related to the strength of the field. Number 4. Recall the difference between gravitational field, electric and magnetic field. Part B. Gravitational force between point masses. Number 1. Understand the meaning of a point mass. Number 2. Recall and use Newton's law of gravitation. F equals to G_m_m over r squared. Number 3. Relate the gravitational force to centripetal force. Number 4. Understand the meaning of geostationary satellite together with the conditions for Earth, the orbital period of 24 hours, and the satellite must orbit the Earth from west to east above the equator. Number 5. Derive and define the gravitational field strength represented by G due to a point mass. Number 6. Introduce and understand the meaning of inverse square law. Number 7. Understand why G, which is the gravitational field strength, is approximately constant for small changes in height near the surface of Earth. And number 8, recall and use G equals to Gm over r squared. C. Gravitational potential. Number 1, define gravitational potential at the point. Number 2, recall and use gravitational potential equals to minus Gm over r. Number 3, explain why gravitational potential at a point is negative. Number 4, use and perform calculation involving gravitational potential due to a point mass. Number 5, be able to draw graphs of gravitational potential against distance. Number 6, understand how the concept of gravitational potential leads to gravitational potential energy. Number 7, understand that a satellite orbiting a planet has gravitational potential energy and kinetic energy. And number 8, understand escape velocity. Number D is the formulae for this chapter. Number 1, the gravitational force F equals to Gm_m over r squared. Number 2, angular velocity, which is omega equals to 2 pi over t, or omega equals to 2 pi f. 3, gravitational field strength G equals to Gm over r squared. Number 4, gravitational potential is equals to minus Gm over r. Understand the significance of the negative sign. And number 5, gravitational potential energy is equals to minus Gm_m over r. E, the past year examination question. These are the examination questions that has come out in the examination since 2021. Number 1, it is important to write an equation involving the variables given. Number 2, the equation is centripetal force equals to gravitational force. This is because the gravitational force provides the centripetal force needed for a planet to orbit around another star or planet. Number 3, you can equate mv squared over r, which is your centripetal force, equals to Gm_m over r squared. If you need to calculate the speed of the object undergoing uniform circular motion, or to calculate the kinetic energy of the orbiting object. Number 4, you can equate mr omega squared equals to Gm_m over r squared to get the relationship between t squared, which is the period, and r cubed. You can also equate Gm_m over r squared equals to mg if you need to calculate the gravitational field strength G. Conclusion. There's always an examination question on this topic in every paper. Paper variant 4.3 is similar to paper 41, variant 41. Hence, for example, paper October-November 2022, variant 41 is the same as October-November 2022, variant 43. F summary. In the next video, we will solve the questions on gravitational field from the year 2022. The year 2022 is important because it is the beginning of the new syllabus. Number 2, the focus is on the content knowledge that you need to have to solve the examination questions. Number 3, at the end of each question, we will summarize the facts that you must know to solve the examination question. Number 4, we will also pay attention to the formulae that you need to equate to set up the equation to solve the numerical problems.